Hello, you are watching the Plop-Fizz Lab demonstration. Feel free to follow along and perform the lab with me from home, or follow along and record the data that I find. Now, I recommend you definitely making a copy, printing the lab, because we're going to be following along and filling in some information as we go. And one thing I like to do is make sure I've gathered all my material. So I've read through all the directions, have a bit of an idea of what I'll be doing. So here are the things you need. Now I added one item, by the way. So let's go ahead and look at what you need. The first thing you need are some clear glasses. So I have a few different choices here that I was able to find from home and from the lab. We also need some Alka-Seltzer tablets. And I know that we need to prepare them a couple of different ways. We need some that are half, some that are broken into fourths, and then we also need some ground into powder. Now, good scientists do trials, which means they run the same experiment several times and collect data and then average their results. So I have 3 of the powder for my 3 trials. I have 3 of the quarter pieces, and then I have 3 halves to conduct my experiment. I also need, it said, a mortar and pestle. Well, I didn't have one, so I used a spoon. So you can definitely grind up your Alka-Seltzer with the back of a spoon. And a stopwatch will be needed. And you also need some water. And you are required to measure out 200 milliliters of water. So I have gathered a few different graduated containers to do that. Now I wanted to talk a minute about graduated containers. These are called graduated cylinders, and graduated just means that they have markings for measurement. So this actually goes up to 100 milliliters. This little one goes up to 10 milliliters. You also have this graduated container at home, I'm sure. It has markings for measurement. We don't want to use cups though. In science, we use the metric system, so I can measure out using my measuring cup. And then I also have other graduated containers called beakers. I have a small beaker and a larger beaker. So for the case of this experiment, if you're following along at home, feel free to use a measuring cup. I will be actually using this small beaker here because it's marked off to 200 milliliters, which is exactly what I need. So before we start our experiment, I wanted to give a little lesson on what's called the scientific method. Now, the scientific method is the steps a scientist will follow to solve a problem. So we have a specific problem for this activity, and if you look at the top of your sheet, the problem is right at the top. So in this case, we are trying to decide if the physical size of an Alka-Seltzer tablet affects how fast it dissolves. So we're going to be looking at different sizes, at halves, quarters, and powder, and to see if they differ in how they dissolve. So after we have our problem, the next step is research. Now, the reason the scientist does research next is because they want to be educated on all the different studies relating to their topic. They won't be able to make a hypothesis, which is an educated guess, until they've done a little background research. Now, the research is provided on your sheet, so take a moment to read the background, and it'll tell you a little bit about the history of Alka-Seltzer, as well as some of its components here. So our next step then is our hypothesis. A hypothesis is an educated guess. So now that we're educated a little bit about Alka-Seltzer and its reaction with water and with between citric acid and sodium bicarbonate, we're ready now to make our hypothesis. So if you look at your form here, it says hypothesis, I think, because. So here's where you get to guess. I'm not going to tell you any answers. We know that our problem is if the physical size of Alka-Seltzer will affect how fast it dissolves. Do you think that the half will dissolve faster, the quarters will dissolve faster, or the powder will dissolve faster? That's our experiment. So go ahead and make your prediction. I think that, and tell me what you think will happen. So now that we have our hypothesis, the sheet asks us to write something else. We need to now identify the variables. So let me explain variables a little bit to you. This experiment has a couple of different variables. The first one is called the independent variable. So the independent variable is what we are changing. So in this experiment, what am I manipulating? What am I changing? That's right. What I'm changing is the size of the Alka-Seltzer. So I am changing if the physical size makes a difference. So I'm changing the physical size of the Alka-Seltzer. So that then is our independent variable. Now the other variable is the dependent variable. Now the dependent variable is what I'm measuring. So what am I measuring in this experiment? What tool am I using to measure? What's my result going to be? That's right. My result is going to be the time it takes to dissolve. So time to dissolve is my dependent variable. Okay, so now that we have our problem, we have our research, we have our hypothesis, and we've identified our variables, it's time to begin the experiment. So now I'm looking at the second page, which has the instructions. And I'm first going to work with the whole tablet, which in this case is a half. So I have my half tablets right here, and I have my lukewarm water, and I need 200 milliliters. So I'm actually going to use this little beaker here. You can also use a graduated cylinder. Now it's best to lay it on the table, not to hold it in my hand, and to try my best to get it right at 200 milliliters. And what I want to do is get my eyeball right down to the line, and I'm looking for the bottom of the line to be matched up with the 200 milliliter line. So I'm trying to control all the other variables. I don't want to change my container. I don't want to change the water I use or the measurement, because that could alter my results. So I want to keep the measurements as accurate as possible as I do this experiment. So I'm supposed to drop my half of Alka-Seltzer into my container. So I'm going to pour in my 200 milliliters. And I'm going to get my stopwatch ready. Here it is. And I'm going to begin time as soon as I drop in my Alka-Seltzer. So here we go. Very exciting stuff. Now it doesn't say to stir it, so I'm just going to let it do its thing. As you can see, there are bubbles, and so I know that that carbon dioxide is being released. I know that there's a chemical reaction going on. And again, I'm waiting for it to dissolve, and almost there. And it is gone. So, according to my stopwatch, there we go, that took about 42 seconds for that to dissolve. So now you're going to record information on your data table. So there you go. So we did a whole tablet, and that's called trial 1. So go ahead and write down 42 seconds in that little box. So I'm going to go ahead and do this 2 more times and have you record the information. So I did my trial again with the whole half tablet, and I got 43 seconds. And now I'm ready to begin my third trial. So I'm going to add in my Alka-Seltzer, get ready to time it. Going now. And go ahead, and in the first box, trial 1 was 42 seconds, trial 2 was 43 seconds, and we're waiting to see how this one dissolves. Chemical reaction. Now sodium bicarbonate is a base, actually, and citric acid is obviously an acid, and so when those two meet, they neutralize each other, and it looks gone. So that one was a little quicker. That one was actually 34 seconds. So my first 2 were pretty close, but my third trial was 34 seconds. So I'm going to add that in. There we go. Now what you need to do next is calculate the average. So how do you do average? You add the 3 numbers and divide by 3. So go ahead and do that now.